Okay, I'm first, so I think we're good.
Hey, checking my mic. Can you hear? Can you hear me?
Yes, we can hear you.
We can hear you well, Care.
Thank you.
Care, whatever the speakers are doing, they're interfering with the my hearing aid. So if I miss something, make sure to speak up. Speak up. Okay, I'm going to start with
Will do.
I'm going to start with IDR status. We had a little bit of interesting um, uh, information on early allocation. So I've added some early allocation slides, thanks to Bruno and Robert. So this is the status from Monday. The charter, we're working on a rechartering. It's on GitHub. Our status is on GitHub. I just sent off, we sent off draft ITF IDR VPN prefix ORF, and Caton is this too hot? Should I be standing back, guys? Hot meaning it's too sound. How's the sound? Okay, thank you. NRP is ready to go off. I just have to push the button. And next top draft ITF IDR NHC, John needs to make one more correction. The rest will come shortly as the shepherds work through them. One that's probably the last is the CT SRV6. That takes a bit of spring. Okay, need your comment. How many people are waiting for a draft to go in adoption? People here? Yeah, well, if you're waiting, please answer the other calls, because we deal with the calls, we have to complete them, and then we go on. Okay, sedge list is in the middle. The sedge list, why sedge list is sitting there, draft ITF IDR SR apology sedge list. When we went through with NRP, we did the working group last March, and then the post process took us a year. Okay, why is that? Because we didn't carefully plan for the interactions with Spring. So, okay, early adoption cleanup. I'm going to restate some basics. No early allocation should be used in a release product unless it is assigned by IANA or it's a new registry specific to your draft. If you don't know what that is, talk to me. I'll be glad to walk through the process with you. But Bruno and other people have noticed things in the wild. Why did that occur? Part of it's my fault, okay? RFC 9830 SR policy was delayed based on lots of things and people wanted to work. My error was trying to give some advice to implementers, realizing I thought you'd be working in your labs while we tried to get it done. That's really not the right way to do it, okay? I've been trying to slowly clean it up. We have a long-term thing. And by the way, Adrian warned me it was a bad idea, and I didn't listen to him carefully enough. So mea culpa, that says I apologize, it's my fault. Long-term, IANA is revising their policies. They're revising their policies for early allocation and even considering an early registry, so that if we had SR policy and we were at the last place we were, we could use that. But it's in process at IANA BIS. That's a working group. If you're interested, join that working group. But if you just want your IDR allocation, come see me and we'll work through it. Okay, second thing that caused it to NRP to be delayed, we didn't carefully link the BGPSR and BGPRSRT to Spring concepts. Then when you get to the last call, it says, oops, it doesn't have the right support. Okay, so Sedge List hit that, and we're talking about it on the spring list. NRP took a whole interim to talk about it. That took 9 months to get through. Okay, so to better coordinate anyone who uses Spring, I need you to put in a cross working groups section. This means when the reviewers look at it, they will say, oh, look, that's the draft and the concept I'm trying to make a mechanism for in Spring. If there's a link to the PCE, because another question that came up is, oh, can we set NRP via PC? How does that interact? And then if it's absolutely needed in an SRv6 op, say you're China Mobile, China Unicom, some of the other big players who've done SRv6, put it in there. IDR has long had the attitude, if an operator needs it, it goes to the top of the list, because we're all about building things for operators. Okay, so if you want more about the problem, come to Spring. I'm got a long discussion. Other than that, IDR is busy. If you be ready, right, I'm going to finish this within 3 minutes if I'm good. So stand up and come get ready, because we'll pick it up. We have this morning SR policy metric. And policy metric has a few things in its early allocation, but we're not going to talk about that. We're going to have her go through the information about the draft. Draft ITF, IDR, BGPLS, BGP only, fabric. Avinda has some things to say. Again, these are 2 adopted drafts. Then we have new core features from Chang Wang and Zhen Huang. Their core features, we're now starting to tell you if it's an SR policy, an SRTE, a flow spec, or BGPLS. So a core feature says it's not in that. It just, that's how we're categorizing it. Our AD has asked us to do that so we can see how our drafts go, that we're progressing enough in each category. TE is next, BGPLS is next, and then another core signal one by Manakamba. He switched with someone on Monday, so we fit him in at the same time. At the end, BGP flow spec, and at the end, we'll have a presentation from a student on how he's looking at some BGP convergence. He's at the end. We're going to slip everything in so things are tight. Okay. Slides. Do I have to take it back?
Yeah, take it back first.
From the clicker to
Yeah,
get it?
yeah, yes.
Yep, okay.
And
little bit.
so share it, share, click it again.
Pardon?
Share slide, the share slide.
Yep, I
button,
got your
yeah.
slides. We got 2.
To this
There we
one,
go.
yes.
Okay.
And the clicker. Okay.
Okay, hello everyone. This is Ka from Huawei, and my topic is about the BGP policy extension for metric, and this draft is in the working group version 4. And we add metric information to BGP SR policy SAFI, and the metric of SR policy can be used for next hop selection. And the metric subTLV is and the segment list subTLV. And from last version, we have got some comments. And the first comment is from Curtin. It is about the metric type registry. And in this draft, we need a new metric type registry and the BGP tunnel encapsulation. This metric type is identical with the BGP LSSR policy metric types. So Curtin suggests that we reusing the existing registry for BGP SR policy SAFI. And it is clear that the metric type defined in this draft is the same as the BGPLS policy metric type. So we can reuse the code points, but the question is the name. The name for the BGPLS SR policy metric is the name is BGPLS SR policy metric. So maybe we can rename the registry. And the next comment is from Amanda for Anna review, and it is about the one is about whether to use a new registry is required, and in this case we clarify that a new sub-TLV registry is required, and as a policy segment list sub-TLV registry, and then we will update the reference to BGP tunnel encapsulation registry group. And also, as in response to Curtin's comments, a new registry for metric type would not be needed. And then we got some comments from Zhenqiang, and the first comment is about the metric regularity, and the segment list represents the active paths, data paths, and the metric can vary from different data paths. So we propose that the metric is a per segment list attribute, and this has been aligned and agreed offline. And the second comment is about the to clarify the usage of metric, usage of the SR policy metric in path selection. And the usage of the metric is illustrated by an example in this document, and we will further refine and elaborate on the usage of SR policy metric in next version. And then is some comments from Susan, and it is also about the registry for SR policy segment list sub-TLVs, and we will update this in next version. And also we will update some reference of the draft to FC, and then we will add some security description for the metric usage. And we also will fix the table format for code point 5 of metric type. And then next step, we will fix all the technical and editorial issues in next version. And then we will finish the code point early allocation. And then we will request a WG work group last call. Thank you. And any comments?
So Ka, the one thing we need to do fairly quickly is, what if you have time, we're here to go talk to Amanda together and make sure everything's working for your allocation. You've done some excellent thing, and then we can go back through a working group
Okay.
allocation call. Did you make the other corrections to the draft?
No, I will update it later
Okay.
in the next version. Yeah.
So after we talk to Amanda today, maybe after IDR, we can confirm that everything's fine with her.
Okay.
So that doesn't take any more delay. You make the corrections, and then we'll do a second working group allocation call, and then you can head toward working group last call. Yay.
Okay. Thank you. Thank you very much.
Thank you.
Okay.
Please go ahead.
Yes, Zhen Qianglin from China Mobile. One more actions for the next steps. As discussed and agreed with the experts from Huawei and China Mobile, this draft should be merged with my draft, and we all agree with it. So that's a important action for the next step.
Okay, we will discuss it later offline. Okay.
Any other questions? Otherwise, we'll go right to the next speaker. Thank you.
Thank you.
This one. Yep. It's a vendor.
Yeah.
You should have the control.
Yeah, I have the control. Thanks you. Hello, good morning all. I am Arvind Babu from Cisco Systems. Today I'll be presenting the updates of BGPLS for BGP only networks on behalf of my co-authors. Yeah, let me quickly explain what this draft is proposing. BGPLS, originally defined in RFC 9552, was designed to export link state and traffic engineering information to the northbound. Historically, BGPLS has focused on distributing information learned from the IGPs. RFC 9086 expanded this by introducing BGP protocol for exporting EPE links. This draft defines the mechanism to distribute network topology and traffic information in the networks where BGP is the only routing protocol. So why is this required? Many data centers, MSDC fabrics, and emerging AIDC networks run BGP as the only routing protocol. Unlike IGP networks, BGP only deployments do not have a standard way to expose full underlay topology and traffic engineering information to controllers. Topology visibility is increasingly necessary for optimized fast convergence and resilience solutions in data centers. Refer ongoing discussions in RTGWG on the topics listed like AAML-driven IPFRR and resiliency optimization, efficient route protection, IP fast reroute in BGP-only networks. So by exposing these topologies, we can enhance TE capabilities, ensuring efficient end-to-end traffic engineering between data centers or WAN. So how is this done? Each BGP speaker is enabled to advertise its own local topology into BGPLS using the standard NLRI types, node, link, and prefixes as defined in 9552. The draft mostly reuses the existing BGPLS descriptors as well as the attribute TLVs. What the draft adds is the procedure for how those NLRI TLVs are advertised in a BGP-only fabric context. So it also introduced a new BGP route type TLV in the prefix descriptor so that the receiving system can correctly understand the type of BGP derived prefix information being carried. Beyond that, the approach is intentionally conservative. It reuses existing BGPLS attribute TLVs and does not introduce any new attribute TLVs at this stage. So what remains the same? This draft is intentionally made non-disruptive. It does not change the base BGP underlay, the IPv4 and the IPv6 routing behavior, or the normal BGP decision process. It also preserves existing peering models and operational design. The current text mainly focuses on the common eBGP single op model mentioned in the style RFC 7938. But at the same time, it does not rule out any other peering approaches. And the BGPLS sessions to controllers simply ride on the reachability, which is already provided by the underlay. So the key message is that this adds topology visibility without requiring operators to redesign how the fabric itself routes. So what are the different modes of deployment? The slide covers two different modes. On the left is the distributed mode, where each router shares topology information through the route reflector, and that information is distributed back across the network or to the other routers. What we have on the right side is a centralized mode where one or more BGP speakers or route reflectors, they consolidate these topology info and provide them to a controller for achieving end-to-end visibility and centralized computation. So meanwhile, the routers continue to run the underlay for IPv4, V6, or exactly as they do today, using standard BGP decision process to build forwarding. So what are the topology information advertised? We right now advertise node level information like node name, BGP route radiation, link level information like link name, link IDs, addresses, bandwidth, SR adjacency sits, prefix information like SR prefix sits. But in general, other BGP TLVs can also be leveraged based on the use case. So the as next steps, the implementations are currently underway. Based on the experiences from the implementations, the draft will be updated. We'll also be requesting for code point allocations. Finally, we invite review and feedback from the working group to advance the proposed extensions. Thank you. That's it I had.
So I'm going to ask this of our AD, Caton. Caton, is there anything special that we need to check before on this draft before early allocation request?
So speaking as a co-author and not as AD, as Arvind mentioned, we are still not at the point, but we'll be there soon, asking for code point allocation. But this would be BGPLS, so it would be the normal expert review process. It's not an early allocation process.
Okay. So help me when we get to the allocation to remind me you're an author, so I find someone. If we need something.
This is not does not need a early allocation process. This goes directly to expert review process.
Okay,
It's
thank you.
BGPLS,
That's what I
so,
thought.
yeah.
You can just go to the expert review. Okay, thank you. Any other comments on this draft?
Hi, Keyur Patel, Arcus, speaking as a working group member. Minimally, you should cross-reference this work with LSVR because the extension, while IDR handles LS extensions, this extension for LS is predominantly defined for data center use cases, it seems like, which is handled in LSVR. Thank you.
Thanks, Kate.
Kriti, you're next.
Hi, Kiriti. I was trying to write this draft. I probably messed it up, as Robert pointed out to me. So I'm happy to talk with the authors and understand what they're intending, but this is exactly what I wanted. The one thing I wanted to add to this is to add node capabilities, which I don't know if BGPLS carries today. Because I want to understand which nodes are capable of doing certain things. So there's an IGP extension that will allow you to say this node can do X, Y, Z. So we have a draft in LSR that adds node capabilities for MPTE, multipath TE. I want to carry that as well here. Other than that, I think this draft does what I need.
Yeah, thanks, Kirti. We can discuss and consider the comments and add further extensions. Thanks.
Okay, thank you.
Oh, fortunately, we have one of the co-chairs of LSR, so I think they've written it up. Anything else? Okay.
Thank you.
Okay. Just let me, I don't have it. Did you already set up? Nope, here we go.
You click release from environment.
Yep. No, I did, I've got to get the other slide.
Share it to the slide.
Yep, I've got it.
That's
Did you already put the slides up?
Yeah, I already put in there. Share slide. Click the share slide.
You put the next slides up? Yeah. Okay. Okay, that's what I was asking. We're in interface capability. Yep,
Interface capability.
I got it then.
Okay. Hello, everyone. This is Changwan Lin from H3C. I'm going to present this draft. Our co-author from Kevin from HPE. This draft is about interface index capability for BP. First, we can see the background. In the right picture, two different AS established three
Little
parallel.
farther back from the mic. Just stand,
Yeah, okay.
not closer. That's good.
Yeah.
Go ahead.
On the right finger, the different AS established three parallel number peer links. These three parallel pairs have same local address, peer address, local AS number, remote AS number, and these parallel pairs cannot be distinguished by this identification. So interface index need to be added for identify local number pair. And also the local interface and the remote interface need to be added for association, the local number pair and the remote number pair relation. IGP has the mechanism to learn the remote interface index. For OSPF, the interface index TLV defined in OSPF hierarchy packet. For ISIS, the extend circuit ID TLV defined in ISIS hierarchy PDUs. So for IGP can learn the remote interface indexed, and the IGP can get the remote identifier before advertising this link in LSDB. But unfortunately, in BP, BP has no such mechanisms to get the remote number interface index. There are some use case. First use case for BPLS SPF in the right finger, the two AS established three parallel number links as described in RFC 19815. For a number links, the link local and the remote ID are used. It also recommends that the local remote ID should be known, but this RFC doesn't define any mechanism to learn the remote interface index. For BPLS SPF calculation, when it runs the SPF calculation, the two-way link checking should be processed. We need to use the local link to find the reverse link. If BP does not have the remote interface index, the bidirection checking will become a problem. Another use case is for BP-EPE. When BP-EPE report BP topology, it contains the linker NLI and the linker NLI's attribute. As described in RFC 1986, the linker NLI include the local node description, remote node description, and the link description. The link description must include the local identifier and the remote interface identifier. For the same example, when the parallel number BP peers report BP link NLI to the controller, if the link NLI does not contain the remote interface ID, then the controller cannot map the local EPE link and the remote peer link NLI. So the controller cannot associate the local peer link and the remote peer link. The solution in our draft is same for for the IGP mechanism. We learned the remote interface ID before establishing BGP peers. The routers exchange the local interface ID by open message. Then after BGP established BGP peers, the BGP can advertise the links with the linker with the local and the remote interface index. Finally, we can see the protocol extension. Our draft defined a new interface index capability TLV in open message. When receiving open message contain the remote interface index, then BGP can record the remote index. Then when BP advertised BP link information, it can contain the local and the remote interface index. Yeah, that's all. Thanks for Sue for her reviews and suggestions. We will update the draft accordingly. Any question, comments are appreciated.
Hi, Kiriti. Since the theme is to do IGP and BGP, I think this is useful.
Thanks.
Thank you, Creedy. Cute. Is there any other comments online? AC, you are online. Please go ahead.
Hopefully you can hear me. This would help for one of the cases in BGPLS SPF as well. If we had, I'm not saying, I haven't thought about this. I didn't read this draft before, but knowing it would help disambiguate and identify unnumbered links in BGP LS SPF as well.
Okay, I encourage people to think carefully about this draft. It asks, and we'll have the authors come back, but I really think you need to look at this one and evaluate, is it worth the risk? Okay. Creedy, you may go again.
Thank you, Kiriti. So I think the high order bit here is in data centers, people don't run IGP. And I want to know why. I mean, this has sort of been the Bible for so long. So that's why we need this draft. That's why we need the previous draft, the draft I was trying to write, which I didn't do well, basically to essentially use BGP as an IGP. I understand everything about dump trucks, but we're not actually changing what BGP is carrying. That's already done in BGP-LS. We're just changing the mechanisms. But really what we're doing is reinventing IGP in BGP because people don't want to use IGP in data centers. So if someone figures that out, we don't have to do all this, but we have to understand why this is happening and what the antipathy to IGP in data centers where that comes from.
Go ahead, Tony.
Tony Lee. I'd like to answer that question. Long ago, far away in a galaxy not too far from here, someone built a data center and used OSPF. And they used a particular OSPF implementation, which was not fully mature. And they had a bad time. They had a very bad day. And they started looking for other solutions. And a person at the vendor sat down in the lab and did a study and showed that BGP sent fewer messages than OSPF did, and therefore they should try BGP. And the data center operator looked at that and said, oh joy, oh wonder, we'll try it. And they liked it. And they liked it so much they published an RFC in its informational status, but it became gospel in the industry. And now when you go to a data center operator and ask them to run an IGP, you get back a scatological response. So the industry is locked in on an IGP. Both Tony P and myself have tried to redirect them and give them better solutions, but they are extremely resistant. This is an installed base problem, and they have all the money, and they are very happy with their solution. They have no pain points, and what we think doesn't matter.
Thank you. Jeff, you're next.
Hi, Jeff Haas. So wearing partially my chair hat here. We're seeing a number of extensions coming out in a number of different places to expose link endpoint information. So the draft here is, effectively, how do we get visibility about IF indexes? We've seen at least 2 proposals this week in different groups about ports. We've seen other places where this ties into other flavors of traffic engineering. So the thing I'm flagging here for the working group to pay attention to is, as we get to all these different ways of trying to expose, the hidden inner details of how the links are actually attaching to devices, we should be careful to try to pick a consistent solution for that. That's it.
Okay, we're going to have to cut the line at this point because we're behind, but thank you, Chan Wang.
Yeah,
I
thanks.
encourage conversation on the list on this draft. Thank you. Please, next draft.
Release it first.
I've
From
got to
the
get,
clicker,
yeah, I should
right
get,
side.
yep. Got it.
Clean it. You could clean it again.
Got it.
No.
Nope.
Oh, yeah.
Got it. Should be yours.
Yes. Good morning. My name is Zhenqiang Li from China Mobile. On behalf of the co-authors, I'd like to present this document, BGP extensions for network resource partition. It is a very simple draft. A new type of BGP extended communities is introduced in this document to carry the NRP ID information. So why do we want to do this? To decouple SR policy from NRP
Greedy,
to increase
one
this-
conversation.
Sorry?
Excuse me, I was just telling Krita to go back to his seat. Thank you.
Okay, so the motivation is to decouple SR policy from NRP to increase the scalability of NRPs. Existing approaches band SR policy to NRP on a one-to-one basis. Draft SR policy NRP extends the BGP SR policy protocol to distribute the NRP ID and its associated SR policy together. When the SR policy is delivered from a SDN controller to the headend node in the network, as shown in this picture. So this solution is feasible and can be deployed within a limited domain with a limited number of NRPs. However, it lacks the flexibility and incurs significant operational overhead as the number of NRPs scales. especially when multiple NRPs share the same SR policy path. Please look at the picture below. Three services demand three NRPs to meet the low latency and bandwidth requirements. In this scenario, the controller has to set up three SR policies, and these SR policies share a common low latency path from A to F. BFD or SBFD session is usually needed for each SR policy to quickly detect the liveness of the policy, right? So how to do it? Extending BGP rather than BGP SR policy to advertise NRP ID information in routing updates between network nodes directly. This solution decouples SR policy from NRP while coupling NRP with the services that demand the corresponding NRP for forwarding resources. Our key idea is that it is the service, not the SR policy, that requires NRP. Our solution allows multiple NRPs to share a common SR policy path, thereby avoiding linear growth of SR policies. This eliminates heavy OpEx burdens related to SR policies, removes duplicate SR policies, and avoids the need for associated BFD or SBFD sessions. NRP ID is carried in a transitive opaque extended community. We call it NRP ID extended community attribute. The format of this attribute is also very simple. A new tab code is requested to be assigned by IANA. And currently there's only one field is defined in it, that is the NRP ID. The procedures, first is the prerequisites. An appropriate SR policy has been set up, and the forwarding resources for NRPs are reserved. All nodes along the SR policy path support the data plane encapsulations methods for NRP. How the prerequisites listed here are satisfied is out of scope of this document. For BGP updates, according to service requirements, the endpoint node carries the NRP ID information in the NRP ID extended community attribute introduced in this document when advertising service rules to the heading node. Upon receiving BGP updates with NRP IDs, the heading node associates the NRP ID in the routing update with the corresponding rules. And for traffic forwarding, the heading node, when it received a packet matching the BGP route corresponding to a SR policy and an NRP, the heading node encapsulates the packet and forwards it to the first segment of the corresponding SR policy. Then the packet is forwarded with the network resources corresponding to the NRP ID. As a specific data plane encapsulation, we do not touch it in this document. And for the intermediate node, it forwards the packet along the SR policy path based on the destination IP address. Actually, it is a seed in the SR policy scenario. Then the packet is forwarded with the network resources corresponding to the NRP ID carried in the packet, whether it can be carried in the source IP address or the extension handler. For the endpoint node, it decapsulates the packet and forwards the inner packet accordingly. Oh, that's all for the procedures. And the next step, further reviews and comments are greatly appreciated. That's all for my presentation.
Tony, you're still in the queue. Did you want to queue up this or do you want to just, okay, then Zafar, you're next.
Hi, sorry, thank you. If you go to your slide number 3, the thing is this, that the SR policy color already showed the intent. So this whole idea, the carry another ID to show the intent is not needed. In fact, the reason you're having an issue on this slide, it was slide 3 actually, is that the construct for the NRP in the draft IETF is also very loose. Is a control plane instance, is a data plane instance, is the intent. If you go to slide 3, yeah. So if you only want low latency slides, you don't have to create 3 NRP IDs for that. That is can be encoded with one color, and that's what we do today. So I think this whole thing needs a lot of clarification, and actually in draft IETF as well, which there is a spring draft, there is an IDR draft. This is where the clarification needs to go. And once those clarifications are done properly, then you shouldn't have this issue that you highlighted.
So,
Zafar, to clarify your comment, you're commenting not only on this, but the draft in spring and the current one that we passed working group last call from IDR?
Yes, because the intent, the NRP ID itself is used very loosely, what it is, and then people think, okay, NRP ID is carrying low latency intent, is a control plane construct. You already have control plane construct in SR policy to give differentiation or satisfy the intent. So there are quite a few of things. I don't think we need this draft because this could be done with color, but I think what needs to happen is this clarification in the IDR and in the spring draft. There were some comments, I believe, when this work was being done, but there is still some discussion there.
Okay, I will talk to Spring today about this and mention what you said. Drop me a note in email, would you? Thank you.
just
Sounds good. Thank you.
a quick clarification.
Okay.
This
Any other comments on this draft? Okay, we're out of time. Thank you so much. Yes, right one.
Hi, good morning. Good morning, everyone. I'm Song Liu from China Mobile.
Yep, all set.
And I'm going to give a presentation about BGP SR policy adaptations for BFD configuration. Let's begin with the motivation. In controller-based developments, SR policies are typically distributed using BGP SR policy or PCP. However, in current developments, SR policy provision and BFD or SBFD configuration are performed independently, often through manual configuration, netconf, or additional automation mechanisms. This separation introduces several operational challenges. The first is increased operational complexity and the longer provisioning time, and the potential inconsistencies between SR policy and monitoring configuration. While PCP adaptations to carry BFD parameters for SR policies are already available as a working group document, and this proposal focuses on BGP adaptations. We update the first version. We received feedback from experts, and we update the new version. And this version updated TRV coding with BFD or SBFD parameters and clarified the relationship to RFC 1926. The RFC 1926 defines a new BGP path attributed to associated BFD sessions with BGP routes. However, to use RFC 1926 for the SR policy use case, additional consideration would be needed. In particular, it may require enhancements to the SR policy model to interpret and act upon BFD state at the candidate path level. In addition, support for SBFD would need to be considered. This path would likely require further discussion in the working group. This document extends BGP SR policy defined in RFC 9830 to distribute BFD or SBFD configuration parameters alongside SR policy candidate paths. New optional subtheories for BFD or SBFD monitoring are defined within the tunnel encapsulation attribute. And these subtheories let the controller specify BFD or SBFD settings for SR policy candidate path. And these parameters allow a controller to specify BFD or SBFD settings for a specified candidate path. As shown in the diagram is the workflow. The firstly, controller sends a BGP update message containing SR policy NLRI with new BFD or SBFD subtheories. And the hidden router passes the message, extracts BFD or SBFD parameters, and passes them to the SR policy model. The SR policy model installs the candidate path and in instance the corresponding BFD or SBFD monitoring session. And let's look at the encoding details. We have defined two new subtheories. The first is BFD parameter subtheory, which contains the files defined in RFC 15.8 and 80. And the second is SBFD parameter subtheory, which contains the files defined in RFC 17.8 and 80. In both theories, we use flag to indicate what optional files are present. What important point we should explain is the discriminator handling. In classic BFD, the yaw discriminator can be learned during session establishment. So the filed BFD TRV is optional. And in SBFD, the reflector doesn't establish a session or perform distributor negation. Therefore, the initiator must know the reflector discriminator in advance, who is carried in the yaw discriminator field. That's all. Welcome questions and comments. Thanks.
Go ahead, Jeff.
Hi, this is Jeff Haas, and I'm wearing two hats for this conversation. One is IDR chair, and the other is BFD chair. So as we discussed in the mailing list, your slide 5, where you're putting in basically most of the BFD packet itself, is really not necessary. The RFC 9026 work is just basically to say that if you need to have the discriminator or other information passed along to bootstrap the session, you pass the minimal amount of data. So the first piece of advice I'm repeating, you're just looking to pass the minimal amount of state. And that's the discriminator and maybe some of the endpoint information, since this is SR. The second piece of advice is that implementations that are passing the stuff in the control plane don't usually get to set up what the timers are for the BFD session. So while you may have as part of your use case to try to say that a given SR path is supposed to be protected by a specific set of timers, it is unlikely that the implementation will respect those timers passed along in the protocol. So I'd recommend removing those.
Any other comments? You realize Jeff is the BFT chair, right? Yes, okay. I would listen to him. Any other comments? Zafar, if you've got comments, go ahead.
Yeah, I was just wondering, this just become quite chatty. So carrying all the cross dependencies, parameters in the protocol. So I just wonder if like maybe some sort of a profile ID or something of that nature could be done, then device can do the mapping of that ID to whatever local configuration it needs, so that you don't end up doing this chatty business in the protocol itself. It by the way, this is something that PSAP support, this way of doing it.
Okay, we've got about a minute for the last Zhen Khang, if you go ahead, but no one after him. Please go ahead.
Yes, Zhen Qiangli from China Mobile, the co-author of this document. Just a brief clarification. This is the first presentation of this document. Our goal is to align BGP as our policy protocol with PCP. Both BGP as our policy and PCP can be used to provision as our policies. PCP has been extended to support SBFD parameters configuration when setting up SR policies. We believe a similar mechanism should be introduced in BGP SR policy. As for how the method should be implemented and the specific pack format, we can discuss them further, and based on the community input, we will choose and refine our document. Thank you.
I recommend you have a chat with Jeff and Zafar and other people about your idea. Thank you again for your time.
Thank you.
Okay, it's not letting me take it back. Try it from yours. Technical difficulty, just a minute. Unable to attach. Okay, you're gonna have to try. You got it? Okay. Okay,
Share the
let's
slide. You need to stop
try the
sharing
slides,
first.
stop the slides, and
Stop
try the
sharing
other.
and then share it again. Click.
I'm not getting anything. Go with yours. Okay.
Okay.
I'll get out of the whole thing. Just a moment, folks. If there's any comment on the last one, just take a look at the new slide. Thank you. G's
Okay.
got it up.
Okay, thank you. This is Isung from China Mobile, and good morning, everyone. I will present the BGP extension for the SRv6 policy segment list optimization on behalf of my co-authors. The broad background of this proposal is that, as we know, SRv6 policies use a list of the seeds to steer traffic from a head-end node. And the final seed in the list is often the policy endpoint's node seed. But traffic will steer over the policy is already designed to the endpoint of the policy, and including the endpoint node seed in the packet RSRH provide no routing benefit. So this redundancy-based available header space and reduce the forwarding efficiency, especially when the service seed are present in the RSRH. So the purpose of this draft, we want to define a method to optimize the seed list by excluding the endpoints node seed. That means the last node's node seed for the data traffic, and maintain the ability to use the whole seed list, including the last node seed of the last node, okay, for the other purpose, like the OEM. We have a series of drafts about this. So the Spring Working Group has adopted the base draft about the SRE6 policy seed list optimization draft. The draft I am presenting now is it's a BGP SR policy protocol extension here. So for the extension details, we have defined a new flag, means that IF1 flag, install the final node seed flag. The flag that definition we have aligned across the Spring PCE and the BGP RS drafts. So this flag is carried in the candidate path administrative flag step TRV. These administrative flags have defined in the draft link. And the flag semantics is that one, this IFN flag set to be 1. So the endpoint node seed must be included. If it's set to 0, and the endpoint node seed must not be included. That means the excluded for data traffic. And for the operational considerations, when the controller calculates the SR6 policy and distributed to the head end via the BGP SR policy, and the controller sets the FN flag. If set the FN flag to 0, that means for the optimization, and the header receives the policy and applies the logic during the packet encapsulation. So this is one use case for how to use that flag. When we for the example, we have a policy from the PU1 to PU2, and we distribute the candidate path CP1 and list the flag IFN flag, and the seed list here is 3:3, 4:4, 5:5. If the data packet processing to the VPN for the data packet process, the head end will steal a packet into the SRv6 policy because the FN flag set to 0, and it will exclude the endpoint node seed, like the 5:5 from the seed list. It will include the endpoint service seed. In this example, as a 5:100, and the resulting SRH seed list will be the 3:3, 4:4, 5:100. So for another procedure about the OEM packet, like the BFD, the head end will use the full seed list from the policy, and the SRH seed list will be the 3:3, 4:4, and 5:5. Here is the fig on the right. So now we also think the draft is stable. This is the second presentation of this draft, the stable, and we ask for the working adoption for this draft. We also want more further review of this draft. Thank you.
Any comments on this on the list? Okay, I will ask one question. do we have enough experience from SR V6 ops to judge between optimizations? Do you know, Yusung? You're working in all of that.
Do you repeat the question?
The question is deployment experience.
Oh, okay. We have.
Is it driving this?
Yeah. We because we always use the SRV6 policy use the explicit path, and but if we use the loose path, we maybe the last node seed will be under policy, and if you use the explicit path, we have no last node seed. But if we want to distinguish this,
Okay, my suggestion for you is, in my chair hat, is to share that information and the link to the anything that you can publish from SRV6 to let people know about the experience. That's it.
Okay, thank you for your suggestion.
Yes, thank you. You're going to have to do it while I get things preset. Okay. I'm sorry.
Oh, happy Friday. And I'm Yao Liu from ZT. Yeah. So this draft is about the supplement of BGPRS distribution for SR policies and state. A not very new draft. So background, BGPRS can support SR policy, both the configuration state of the headed. So, but a few segment list related information is not included in BGPRS. The first is whether the segment list is in administrative shell state, because we found that in the network, sometimes the segment list may be shut by an administrator. And the second is about is the 32-bit MPLS LSE with non-zero TT and TC and TTL fields. Existing SR policy structure FC already supports to carry the general MPLS label information, the 20-bit label information in the type A SR segment, but the TD and TC and TTL must be set to 0. And the MPLS NMA substack solution repurpose the TC and TTL fields to carry additional information. MNA such as NRP, ROM can be inserted in the seed list in the format of LSEs, and the contents of the LSEs inserted in the seed list may be required by the controller when the headed reports the state of SR policies via BGPRS. And about the extensions, so first is one new flag in SR segment list TRV. So the S flag indicates that the segment list is in an administrative shared state when set. So we remove the B flag, which is the backup seed list flag. And so to be based on the comments we received and to be aligned with SR policy architecture. And the second extension is MNA substack sub-TRV in the SR segment list TRV to carry the MNA substack information inserted in the seed list. So this draft is first submitted in 2023, and version 3 is presented last IETF with the newly added MPLSE sub-TRV for MNA. And last month we present the version 5 in IDR intern meeting. In version 5, we remove the backup flag as I explained it in the previous slides. And the comments received is the first is what's the relationship between the in-stack MNA and SR policy architecture. So it's there's a ongoing discussion in Spring List, so welcome to comment and discuss with us. And the second is how to carry the MNA information in BGPS, use a dedicated sub-TRV or new segment type. So now we use, in this version, we use a dedicated sub-TRV. And the third about backward compatibility considerations. So this version updates are the following. So the first is for the the M&A the name is changed. The M&A substack subtier V replaces the MPLS RC subtier V extension. So considering that there seems no other use cases that need to report the MPLS as is with non-zero TC and TTL inserted in the C list via BGPLS. So besides M&A. And we added backward compatibility considerations. So if you don't recognize the new subtier V, then you skip it and process the remaining part. So that's all. And we also presented this in Monday's MPLS session for review and comments. That's all.
Zafar has a question for you. So go ahead, Zafar.
Yes, I was asking in the chat as well, the same question. Are there implementation that, and my question is only for the S flag under SL. So are there implementation that actually do allow shut of an SL within a CPE? And why is this different than just removing the SL from the list of SL in the CPE? The BGP advertisement already supports CP level shut construct. So I would like to see if there are actually people that are the implementation. If there are no implementation, then maybe we don't have to define that as flag in the SL. And the rest of the thing, I have no comment for the rest of it. Thank you. I hope I'm clear.
Okay. Thank you for comments. I can reply
Yes,
on the
please.
list. And there's some related description in the draft, so I can
take time. No, go reply. Go ahead and take time to reply. We have a few extra minutes.
Okay.
Please.
So my understanding is your question is that why there's a need to shut a segment list, right? So in some networks, so it's totally depend on the network operator. So sometimes they found that the bandwidth so is enough. So they sometimes shut some segment list so they can save energy. So this is a first scenario. And sometimes they do some replanning of the traffic, so they don't want certain traffic goes through this, so don't want this seed list, so they first shut it and to see if it's not used, then watch it for a while. So is the network or running correctly? So then they do some maybe they delete or do some operation. Yeah.
So just a moment. He had a very simple yes/no question. His question was, do you have implementations of your draft?
Oh, yes. So about the S flag, yes, the MA. So for my understanding, there's no commercial the deployment of MA. So
There's no commercial implementations of this draft, but you have implemented it in your lab. Is that what I understood?
So about the S flag, yes.
Okay.
So but MA part, no implementation. But I think this is a topic worth to discussion about. So.
Okay, that's all. That was his, he had a very simple question, and I'm sure he appreciated the other answer, but he also wanted
thank
his
you.
question.
Thank you.
Okay, thank you very much for your time. We're at the save.
Okay.
Right? This is in down. Yes. Right one. Yep.
Hi everyone, I'm Jing Zhao from China Unicom.
How is the sound? Can people hear her or not?
Okay.
You need to stand a little closer.
Okay. Today I'm on behalf of my team to introduce the draft.
Just a minute. You need to be very, hold the mic in your hand. It will,
Okay.
you need to be very close. Speak very boldly and loudly.
Today on behalf of my team to introduce the draft advertising salary related information using BGP link state. First, I will introduce the comment from mail list. The main comment is using BGP-LS to distribute subnet AS attachment information generally may face scalability issues, as our enforcement destination per interface can be very large. But in current, this draft considers the extreme case of ES custom clone, as defined in RFC 8704, section 3.6.1, small medial AS custom clone up to 10,000 prefixes, large AS custom clone about 30,000 prefixes. And next, I will introduce the updates after IETF 124. First is the purpose of what BGP-LS used for this draft. Instead of collecting cell rules from data plane of an individual device, it collects all cell rule-related information for the entire subnet or ASE to which the router is connected. This information enables cell rule monitoring, traffic traceback, and service anomaly analysis, for which dynamic real-time acquisition is critical. And the next is how BGP-LS is used. Routers that support cell mechanisms or protocols establish BGP-LS incidents with the controller to report their melt-sourced cell rule-related information. And the next, I will introduce what cell related information is to be carried. It might be including the source node interface, source prefixes, validation mode. And next is the BGP-OS attribute for cell model. The first is cell mode TLV, an optional and non-transitive BGP attribute that carry that validation model information. It is not restricted to the four existing validation modes in order to support forwarding compatibility and future extensibility. And the next is cell action TLV. The cell action TLV uses the traffic filtering actions defined in RFC 8955 and 8956. A cell rule might be associated with melt source actions, and the conflicts may exist among these actions. And more comment and discussion welcome. Thank you.
Any questions on list? Thank you for your excellent presentation. Well, the next, thank you, I'll be with it as soon as I can, Lana. Should be this, right?
Yeah.
Good morning. This is Mankamna Mishra from Cisco Systems. I hope this is the latest slide, but it's okay. Year ago, we did present one of the draft which talks about the problem statement in IDR. And while having the discussion about problem statement, we came up with a bunch of ways to solve the problem statement. So today, I'm going to present one of the way which we decided to go ahead with. And the decision was based on some of the discussion in the list, some of the offline discussion, and this draft was presented in BES as well. So just to recap, what was the problem? So in general, there are different ways of label allocation mode in BGP or L3 VPN network. And it could be per prefix, per verb, or per next hop received label. Depending on the network, depending on the use cases, maybe one among them will be used. But right now, our interest of area is per next hop received label. So what happens in this case? So let's say this network where I have a router reflector, which is a border router. So we will have next hop self also configured. In this case, when any label is received in a base case from PE1, so both of these router reflector, which is border router, they are going to allocate a label based on the next hop plus received label. So if you look at this picture, we have RR1, which is allocating label as a it received label as a 100, and it allocated label as a 200 and advertised towards the remote side of PE2. At the same time, the peer RR2 or border router 2, and both of the border router are going to do the exact same thing. When they receive each other's update, what they see is the new next hop and new label. So they are going to allocate the label once again, and this label allocation will keep happening till we really run out of the label. And that was the problem statement which we discussed earlier. And two of the solution we thought of, or rather which had the most vote, was going with NHC attribute or going with extended community. But after having some of the discussions, the decision was that it is better to go with NHC attribute, because it provides more way to extend in future if there is a need. Plus there are all the rules which is anyway getting defined in the draft which is mentioned here. So in case of NHC attribute, I think one slide somehow it's missing, which had the picture. We are going to allocate a primary label, and it will be advertised as a part of NLRI, plus one or more alternative labels will be attached along with NHC attribute. And in the signaling mechanism, we have NLRI, then we have NHC attribute. It goes little left side. This somehow it's messed up. So as a part of NLRI, we are going to send the primary label, and your attribute will carry one or more label. So there were some question during best session that do you really need multiple label? And I would say that is more for discussion within working group, that should we restrict only one label or let it be open for multiple label, where different use cases may want to have more flexibility. And for the forwarding model, ingress may choose between primary label and alternative labels. And the selection could be depending on the local policy, what type of traffic, if you want any type of load balancing or any fast reroute. So this will be mostly depending on what operator wants or how operator wants this to behave. And some of the example use cases are fast reroute or for backup path, traffic engineering, and if you want a different label for different path or any service differentiation or any label map to QoS policy. The benefit which we are going to get is now we can have per prefix a different behavior based on the use case or what we want to use or what we want to achieve in our network. And then it definitely avoids these duplicate routes, and it does solve that infinite looping problem. And in fact, that was after best session in last year as well, there were some vendors plus some of the customers who did raise that, yeah, this problem is genuine and it does exist in the network. So the next step will be, please provide any comments if you have. Right, there was a question about whether this draft belongs to BES or IDR. I would say that is more of a logistic question. I would rather first focus on the solution which working group will agree on, and then we can decide whether to move forward in IDR or BES. That is the small thing. Thank you.
Any comments on the remotely or in here? Are we having as we've got in the chat room, the Friday feel of lack of sleep? Okay, thank you.
Number 10. This one? 10.
No,
10.
next one.
Next.
Oh, what we just did. Okay, just this one.
Yes.
Okay.
Okay.
Just
Hello.
Yeah, you should have it.
Okay. Hello, everyone. This is Jimmy from China Mobile. On behalf of my co-authors, I would like to introduce a new draft called BGP Flow Specification Filtered by Destination QP. This draft focuses on the filtering mechanism that combined flows back with destination QP, aiming to provide a more refined solution.
Just a minute. How is sound for people? Does he need to speak louder? Speak louder, please.
Okay, for AI network management and control. And so first, let me share the motivation. And in current network architecture, the rapid development of AI services has put forward high requirements for network transmission, both within and between data centers. So specifically, there are a large number of elephant flows based on RDMA Rocky V2 protocol between GPUs. And these elephant flows are characterized by long-lived, high throughput, and extreme sensitive to latency and package loss. And meanwhile, in an AI cluster, a single task usually lasts for several days. So with a highly stable communication pattern and a relatively stable 5-tuple fields, and the elephant flow always bounded to a long-term QP instance. So this caused some problems. First is link hotspot and congestion caused by ACMP hash collision. Due to the fixed 5-tuple fields and the presence of AI elephant flows, multiple similar large flows are hashed onto the same physical link, instantly triggering congestion. And the second is lack of dynamic adaptability. Traffic is bounded to QP instance even if one congestion is detected on a specific link. Traditionally, ECMP cannot dynamically migrate existing long live flows to ideal link. So to address these issues, the industry has attempted to introduce finer grained load balancing mechanisms such as flowlet and packet level load balancing. And however, these approaches introduce complexity related to package reordering and higher requirements for network chips. And in addition to splitting large flow, a common solution includes optimizing hash algorithm or relying on the terminal network cards to perform a more randomization. But all these methods have some limitations. So this draft proposes a more simple and direct solution by extending BGP flows back with QP to implement a QP-based traffic engineering. And as the QP ID is a unit, the basic unit of RDMA communication, each connection has a unique QP ID. Even if multiple flows share similar IP addresses and ports, and their QP ID will always be different. So leveraging this property, we can we can not only split the large flow into fine grained flows by using QP, but also we can improve the performance of ECMP scheduling and by combined dimensional 5-tuple plus QP. And we also can reduce the dependency on randomization performed by the terminal network cards. So in this draft, we defined a new component type for destination QP from non-IP filters. And then this component is 4 byte long and directly corresponding to the QP number in Rocky V2 packet header. And so in the whole solution, we also had a controller. The controller is responsible for precising the global network topology and computing the control the optimal forwarding paths and generating BGP flow spec rules that include destination QP. And the ingress PE is responsible for passing packages, matching QP, and forwarding matched flows to the designed paths. So this design is safe for all devices because the draft follows the standard precising mechanism for unknown types. So the mechanism enable direct coordination between RDMA layer information and the network layer forwarding, equipping the network with explicit awareness and scheduling capability for AI traffic flows. So the solution has two advantages. The first is finer grand traffic steering. Network can achieve finer grand traffic steering based on QP identifiers, enabling superior load balancing across ECMP groups and enhanced isolation between communication streams. And the second is from random distribution to control the scheduling. Instead of only depending on random setting and end devices, this method gives network operator more precise traffic controls. And next step, we are seeking broader review and feedback from WG. And we're planning to request a new type code point assignment from IANA. So I think that is all. Thank you.
You have two people in the queue. We're going to go right to it, both for Jeff and then Jeff Haas, and then Asian.
Okay.
Jeff Tantoro, NVIDIA. I don't think it's needed. There are zero benefits of doing this centrally. DQP is a fixed offset in BTH. Every modern chipset knows how to read it, how to extract and parse the data. It's a 6-tuple and 5-tuple hashing. All you need, there's zero value in centrally orchestrating it. You just look at QPID, you add it to the hash, gives you arguably better load balancing. There are a number of white papers from Meta, I believe. They've used this technology. The end result is not significantly better than not using it, but practically it makes it much more complicated and, in my personal opinion, unnecessary.
Okay.
This is Jeff Haas. A question for you. Is this a 5-tuple steering that you're trying to do? How is the traffic steered? By the entirety of the IPv4 or IPv6 header plus the encapsulated payload?
I'm sorry, I don't get your problem.
You're trying to use FlowSpec to steer the traffic. This means you must match
okay.
Please go ahead.
So this solution has two steps. Step one is through BGP FlowSpec to steer the traffic to the SRv6 policy, and step two is using 5-tuple plus QP to hash the multiple flows to different SL.
So agreeing with Jeff, if you don't need to actually steer things, based on the tuples, a match mechanism inside of FlowSpec itself is probably not helpful. The second piece of feedback is that FlowSpec is not a fast mechanism. You're programming a firewall, and the firewall will take time to converge. So part of your conversation, when you're looking at this mechanism, is how fast you need this programming to change.
All set, Jeff. I don't want to I'm holding Asian off to make sure you're covered. Go ahead, Asian.
Yeah, I'm from Taiwan. My comment is similar with the comment from Jeff. Normally the BGP flock just filter based on the information from the IP headers, and they have the fixed port reasons. But for the copy information, I think they belong to the payload, and the device need to find the value, where is the copy, and then match the policies may be challenging for the device and the future deployations.
Okay, thank you.
Any other comments? Otherwise, we're over time. Thank you. That was an interesting presentation. Just one.
11. Yeah.
Okay, hello everyone. I'm Yu Jia from Zhongguancun Lab, and the topic of my presentation is about the BGP flow spec extension for feedback banding. And the draft is first proposed on the last IETF meeting, and at this time, I will introduce the expanded framework and some design discussion. And the first is a problem statement. And the BGP flow spec is widely used in carrier network for traffic handling, but the recent flow spec only provides one-way
Yusha,
count.
back up just a little from the mic.
Okay.
Thanks.
Okay, but the recent flow spec only provides one-way control. That's where the successful propagation does not imply effective enforcement. So the rules may become ineffective due to a lot of reasons, such as policy conflicts, installation failures, or lack of matching traffic, and this may persist without timely resolution. And in the control plane, operator can get some information through the routing table, but in the data plane, the enforcement results are not visible. So we think the operator need execution feedback to understand real enforcement behavior and continuously optimize traffic handling strategies. So we try to propose a feedback optimized framework for BGP flow spec. It contains 3 layers, which are the intent plane, control plane, and data plane. And for each flow spec, we hopping the road may carry a feedback can carry a feedback action, and upon the device receives the roles, the router can validate the request and update the state machine and configure the selected telemetry mechanisms. And the router then can report the role status and periodically export hit statistics or other execution evidence. And to achieve this framework, we may have more than one extension of the existing protocol, and maybe have to maintain a state machine in the controller and using the feedback information from the router. And in the control plane, we are trying to giving an extension of the flow spec and giving a feedback action. And also in data plane, it may have some extension of the telemetry protocol. But in the IDR working group, we focus on the extension of the flow spec and giving the definition of the feedback action. That's to helping us to understand the whole framework. I will also introduce something about the state machine and the telemetry protocol. And here is the state machine we proposed, and it consists of some states such as idle, received, or active or inactive. It's still with the it's dependent on the status of the flow spec. And the most important thing, I think, is about the effective state. And because it's may considered about the the hit in the router and also can consider the intent of the operator. So I think maybe it may maintain in the controller and can use some intelligence model to doing that things. And here is the extension of feedback action, and is the most important thing in this draft. And the feedback action is carried in the community container, and it encodes with some fields such as feedback ID, reporting interval, trigger mode, and report scope. And the action is hoping to tell the router the operator needs some feedback, and then the router can doing some configuration. And here are the feedback from the working group through the before meeting, and most of them I think is useful, and we will adjust through the draft. And I think there is a feedback maybe can be discussed in this meeting. And some experts said the BMP as a feedback channel raised the concern about operational overhead. Telemetry, ER notification, and syslog were suggested as alternative or complementary option. And we searched some work on the IETF, and finding there have been a draft about BMP extension of the routing event logging, and it's on the GROW working group, and it's defined some routing event for the flow spec or the SR policy. And so we think maybe it can be used in this framework to giving the feedback action. And we also have some discussion points. And the first is about, I think, can multiple telemetry mechanism can be used together, which clears separation by the plane, because the BMP can only return the information of the control plane, but the young notification, IP fix or syslog, which proposed by the peoples in IDR, may also can give some important information. So I think maybe we can consider it together. And also, some people said the feedback may giving a mission creep. So I think maybe the filtering and the subscription function should be support to avoid existing reporting overhead. And the third question is about the scope of the draft. And I think maybe this draft is only focused on the feedback action. So I'm not sure should we consider to give a guarantees on the state machine or the suitable telemetry protocol. So that's the discussion point. And in the future, we will elegant with the feedback action with the flow spec virtual work. And if anyone interested in this framework, please contact me, and looking for some collaborators. Thank you.
Any comments? I'm sure that you'll be around afterwards if you want to talk about various things. As we work on flow spec, there's a lot of things that need collaboration, and we'll be heading into the flow spec world in the April and May time. Please go ahead. We have time for very short comment.
Yes, Zheng Qianli from China Mobile comment. The work that Yuya is doing is very useful from the perspective of China Mobile and operator. And we can work together to refine the framework you are proposed, and to dig out the most suitable solutions to satisfy the requirements of your framework, such as the interface between the different components in the framework.
Okay, thank you, Zheng Qiang, and maybe we can discuss after the meeting.
Thank you. I'm afraid that's all of our time. Thank you, Yusha.
Thank you, Sue.
AS filters, yes. Okay. Got it. Are you good to go? Yep.
Okay. Hello everyone. I'm Yang Huang from Huawei, and today I want to share the topic about the flow spec IP filters.
Closer to the mic, just a little
Okay.
bit. There you go. Thank you.
As we know, BGP flow spec is about to specify the distribution of the traffic field policy via BGP. It contains two parts, the match condition and the action. Normally, we use the BGP flow spec, use traditional components like components in the IP packets to do the matching filter. But in some scenario, in practice, for example, we need to do the similar thing with different destination but the similar rules like this. If the traffic is user routing path, for example, in the picture, we want to go through the router R1 and go through the R2 to the S3. But if we want to go through route R3 for some purpose, we need to use the flow spec to do a redirection function to do that. But if the destination preface is for several destinations, we are occupied some lots of ACR entries. As we know, ACR entries is limited on the device. So we want to make the flow spec more efficiency. So with a similar action rules, we can use other function like the destination community for the similar rules. Like in this scenario, we can use a BP routers carry a BB community 1.1 like this for the four prefaces, and we can now we only need one rules for this scenario. It's saving the ACR resources. So we need a destination IP community filter. The filter format is similar with other filters, IP filters, where the value is contains a destination IP community. After we present this in IETF 119, there are some concerns about the use of control plane attributes. But we try to reply for this. In our scenario, there is no AS or community information in the forwarding plane. They are used only in the control plane and then converted to one identifier, which represented a kind of traffic classifier. Another is search a field information for more matching information of the flow rule. This is also used by other traffic process technology like QPPB or URPF. Or we can consider it as an extended IP matching filter for BGP flow spec compared to the basic matching components contained in the IP packets. Or so we want to make the flow rule more efficient to use. Or it would be the limitation for us to use BGP flow spec rules. So why this for BGP flow spec? Again, we want to saving ACR resources and the number of flow spec rows when we use a BB flow spec. And I think it is a quick implementation by the widely used BGP flow spec technology. And we can use basic BGP unicast root attributes like AS or community. And it make efficient dynamic flow rules distribution for northbound applications. We have DIP origin AS filter draft submitted in 2019, and other filter draft is introduced later, and we present the draft in IETF 990. And welcome feedback and comments to improve the drafts. Thank you.
Any comments on this? I know we're heading into flow spec and some of the things that are hopeful for that, but there's a lot of work to do. The authors in each of these need a grounding in what's the real use case, what's the flow inside of IDR, meaning the flow for flow spec goes outward in a wide distribution, but getting information back to check on it is a different problem. So please give the authors some comments and go forward. Agent, if you want to talk, you've got the next one.
Yeah, Adrian from Untitled. I think the author has explained clearly the benefit for using the IP as information to replace the traditional prefix filter rules. This can significantly reduce the automation overhead and also the number of the matching rules. Although we call it the BGP flow spec, I think the rule that can be applied to the packet flow can be classified into the BGP flow spec. We should not limit into only the rule that is related to the field in the packet. And another reason, I think we propose such solution because the router has already the information between the relationship, the AS and the IP prefix. So the controller need only download the AS information to the router, and router can do other works for the flow engineering. Okay.
Thank you, Agent. It is a problem that we will probably see a lot of these filters, and so thinking about this particular way to combine filters, think about more. There seems to be in some of the discussions in other working groups need for some filters. Thank you, Yang.
Okay, thank you.
We have one last presentation. It's a student giving us some of his concerns and interests. Give me a moment. Now, I need to explain that he presented his draft on the list, and several people kindly gave him feedback about the mechanism. So I asked him to go back as part of his search and give us the problem statement, because sometimes what we need to hear is the problem statement. So this is his first presentation at an IDR meeting. Be gracious.
Hello, everyone.
Stand up closer. There
Hello,
you go.
everyone. My name is Yu
Can
Hangli.
you hear him? Yes, no? Closer,
Okay.
closer step. Okay.
Hello, everyone. My name is Yu Hangli. I'm from Tsinghua University. I'm glad to make a problem statement about a specific BGP convergence problem and request for the working group feedback. I will focus on slides 5 to 9. It is a very specific case. A route is withdrawn correctly. The receiving AS removes it and runs best path selection again. However, some other candidate paths may still appear usable at that moment, but those candidates can later also be invalidated as more updates arrive. So the network does converge, but it takes several rounds of exploration. This is not a stack route problem, and this is not a zombie route problem. Signaling is valid. The problem is delayed elimination of invalid alternatives. It is a normal but expensive convergence process after a valid withdrawal. This is a simple example. AS1 announces a prefix P/23 to AS3, and it also announces a more specific prefix P/24 to AS2. When AS1 withdraws prefix P/24 at AS3, convergence may not achieved at one step. AS3 may explore paths firstly to 1, and then 5 to 1, and then 4, 5 to 1. Only after that does it converge. So the point is very simple. After a valid withdrawal, a downstream AS may explore paths that looks available for a while but will later fall. So we scope the problem narrowly. The question is, how can we reduce unnecessary path exploration after a valid route withdrawal? We are not talking about for the session liveness detection, permanently stack or zombie routes, policy correct route rejection, or generally security faulting behavior. We only focus on the case withdrawn is valid, routing state is updated normally, but convergence still takes multiple rounds. Then the limited scope leads to limited goal. We want to characterize this behavior, and we want to understand when alternative paths are explored or necessary. We want to know whether earlier invalidation knowledge could reduce convergence cost. We think about that without changing the core semantics of BGP withdrawals. To be clear, I'm not asking working group to evaluate a protocol design today. I'm asking whether this scoped convergence problem is real, important, and worth further study in IDR, and what operational scenarios should ground it. Okay, this is a design question. The question is, after a valid withdrawal, can downstream AS avoid exploring alternate paths that are already doomed to fall? More specifically, can invalid alternatives be recognized earlier? Can convergence reach the final state with fewer exploration rounds? Can this be achieved with operationally realistic mechanisms? At this stage, this is design question rather proposing a fixed mechanism today. Okay, thank you very much. I'm waiting for feedbacks and comments.
So like many of you, I have read lots of BGP convergence documents over the years. I simply ask if he's got a good research problem that you think's useful in today's environment for either the data centers or the edge or something else, that you give him some feedback. If he's really going down something that isn't useful, also give him that feedback. These are, we're hopeful that new minds can think of new solutions if some of us fail, but they need to be guided into the problems that matter. And with that, we are done. You have 1 minute extra. So thanks to everybody for making us be on time. Thank you again.
Hi, Sue. I think AC was in the queue.
Go ahead, Kate. You always get top
No,
priority.
AC was in the queue. I was just saying AC is in the queue.
Thank you.
AC,
Okay.
can you hear me? AC Lindum, Arcus?
Yes, we can hear you.
Go ahead, AC.
Okay, yeah, we recognize this problem for link failures. It's pretty hard for mode failures, and we have we did it for BGP SPF. And what we do is we advertise, rather than withdrawing the link, the originator of the NRLI for the link advertises it down, and it's held for a little while. If you look at, I mean, it's kind of a unique, just one use case of this. But if you look at RFC 9815, section 6.5.1. So we did recognize this exact problem that you had the picture of for BGP SPF.
That was useful information. It's on the chat. He's asking you to look at RFC 9815, section 510. The chat will be available. Asian, did you have something?
Yeah. I have discussed this idea with the author offline, and I think the reason that the AC has such experience, maybe their draft didn't write very clearly. It is not about the advertise the link information within the BGP. They want to solve some problem, some within some complex scenario for the inter-AS links, not the link within AS. I think that maybe they should update their draft and later seek for more discussion in this.
Thank you. Take his advice. And again, thank you for patience in going through this, and we'll close the working group session at that time. Thank you very much.
Thank you.
I tried to get that one, but
Okay. So now